off to Michael and Prasad. If you wouldn't mind putting yourself on mute, that would be great. Everybody that are not the presenters. So thank you.
All right. Okay. Thank you, Brandon and David, for and the whole organizing team for giving us an opportunity today. And by the way, when you said like these are very expert people, Mike, now that's a pressure on us. But don't feel pressured. We are actually here to learn as much as we can from you as well. So definitely it's a give and take. We will share what we have learned so far, and we'll look forward to hearing some opportunities and feedback and comments as well. And that's why there is a survey at the end, right? This is work in progress, definitely not the end. So we're excited to share what we have done so far. So today's topic, definitely we want to jump into, we call it as a ETL, but various names, data processing, you could call them, into cloud, and mainly focusing on Azure Databricks and obviously in the Azure cloud. So on the first slide or the next slide, Mike. Oh, did I forget the intro? Do you want us to do the intro of ourselves, or is not required, Brandon?
Yeah, if I didn't cover anything, feel free to further elaborate on your previous experience or what you're currently doing right now in the field.
Oh, okay, no problem. So my name is Prasad Vaze, for those who don't know me. Been into data field for many years. I won't say exactly how many, and hide my age. But I worked in Capital One for many years, and now recently for past 2.5 years, I'm in Markel. All the while working on data technologies, last 5 years into cloud technologies, including AWS and now Azure, and now more deeply focused into Databricks or open source Spark for data processing frameworks. Mike?
Yep. My name is Mike Noto. I've been in the IT consulting field for about 9 years now, work at Captech. I actually had the pleasure of working with Prasad at Markel on 2 occasions, and also with Dave as well for the first one. And so one of the things that I've really been focusing on in the past few years is more like data development, engineering kind of work. A lot of stuff with Python and with SQL kind of development, and increasingly more focus on the cloud, especially with Azure. And so last time I was at Markel, I got the chance to work on this Azure Databricks framework. So we're excited to show it to you today. All right, Prasad, you want to take over?
Yeah, sure. So let's roll into the first slide, the generic diagram, right? So I won't go through a whole lot of details here because some of you or many of you would recognize this pattern, right? As we transition from on-premise to cloud, even in on-premise, this was true in one way or the other. On the left-hand side is our source systems, and those are external, internal. Data comes through in a batch, streaming mode, real-time, near real-time, right, through APIs as well. And then when we start processing that in that fashion, as per the use case demands, right? And that's a layer, the red circle is where we are going to focus on. The top layer part says Azure Databricks. There are various ways we can process data, and this is one of them. When I say process, what I mean by that is the first steps first, right? We want to validate the data, do some bare minimum quality checks on it. And of course, if it's sensitive, then tokenize it and format it. A little bit of, that happens in initial stages. So that's what the next box shows, the file lake, or we can call it as a data lake, where data goes through life cycle of raw data, then it gets validated, then it gets transformed or refined as per the use case demands. And then it is hydrated or loaded into easy to use SQL consumption layers, right? And those things can happen also in near real time, or on in the batch mode. So that's on the extreme right. You see traditional data warehouse solutions. Today we are going to use Azure Data Warehouse, but you may have heard of or used Snowflake and Redshift and many other. So this is a very generic pattern or diagram depicting the whole landscape. and the focus area being data processing and the hydration, which can be done using Azure Databricks. And the storage is file lake or the data lake in the middle. That includes the data as well as the metadata. So it's completely decoupled storage and compute paradigm is what this diagram is trying to depict. On the next one, now, in data warehousing, a lot of you would have used ETL, and that's the data processing we are talking about. So why Databricks Spark, or why Spark in general, right? Databricks is just a vendor supporting Spark. And of course, they bring lots of bells and whistles to Apache Spark. So why Databricks Spark? We think that this brings best of both worlds. The traditional way of doing ELT, where we used to extract, load data into database, and run a bunch of T-SQL procs or PL/SQL or database procedures to transform the data. So that's ELT pattern. And other traditional tools like Informatica, Ab Initio, you name many licensed tools, they pull data from storage to the ETL server and process it there, and then they push it back, right? So that's a data movement, a lot of data movement. So this tool is basically best of the both worlds. In the first comparison towards traditional ELT, because storage and computers completely decoupled and they can scale independently, we can look to optimize in terms of cost. So it's very cost effective. Then the next two bullets talks about the idea behind this is apply validations or do some common things at a central place. So it increases reusability. So many downstream processes, applications, users can start using validated data. They don't need to run through validations again themselves. So process globally certain parts or as much as possible, but distribute locally. So we can do design data marts or fit for purpose data marts, where you start now taking data further down to the chain and applying specific transformations to distribute them to your marts, right? What the big benefit this approach provides is it allows us to switch the end user tools easily and frequently. And that's where the most churn happens. There are so many BI tools in the market, they come and go and they evolve. Same thing is happening with the SQL or the end user SQL databases, right? So many new databases come. And if we lock the logic in that, then it's pretty hard to switch from one to another and take advantage of the new things that users love. And this kind of moves us away from that and unlocks us. On the second half, the reason it's better than the traditional ETL, as I was saying, it's a cloud native. So horizontal scaling comes out of the box. There is no licensing concern. When I launch a new VM, I don't need to think about installing new Informatica license on the new box to scale it. That's not the need or requirement here. It's open source, but at the same time, it's backed by a vendor. So it's very good because sometimes we need support consulting, a lot of things we need to ask questions. So some vendor is supporting it really well. Then we can run batch and streaming, both types of workloads, unstructured, semi-structured, unstructured data, right? So all use cases can be applied for data processing purposes. Developers love it because they are allowing you to use multiple languages. Pick your language of choice, SQL, Python, Scala, and Java. And then it also, and because R is also supported, it's kind of converging data engineering and science platforms. So a lot of times I have seen that where the redundancy in compute comes from is the transformations that data warehouse IT team does. A lot of them data scientists also do in silos, right? Now, if we bring them to a single platform, there is a hope and opportunity that it would become more reusable and shareable and reduce that redundancy and thereby reduce the dependency as well. So that's kind of a hope still, because it requires some good process and people behind it as well, not just the tool. And the last takeaway really is it fits the modern CI/CD pipelines. So the code itself is not proprietary. It's not locked into the tools repo itself, you could use the Git repo and the modern CI/CD pipelines to open the code, see the code, change the code, move the code. So, and that's why it's good and better than traditional ETL tool. Now going a little bit detail into the framework that we want to show. It's basically a 5-step process, right? The first step, getting or acquiring data from raw systems in any mode, real-time, near real-time, or batch, and then land them into the raw area of your data lake. That's the storage. And then incrementally enrich that data from raw to validated, validated to first refined. Then there is a concept of refined to presentation layer where we will build summary aggregates type of data. So easy to consume, ready to consume, because those are same aggregations probably happening in silos. And this is an opportunity to do it once at one place. And then finally, all the processing of data happens in this framework, in this storage layer, and the end results are loaded into a consumption layer. And pick your choice of flavor of your SQL, right? You can put it into any type of warehouse or relational database so that BI tools become happy, because BI tools typically like querying relational databases. So this is a 5-step high-level process. The next slide actually deep dives a little bit into this process, which kind of shows. So let's address the lesion first. So what you see here is 2 different color-coded boxes, the blue boxes and the red boxes. And the intention to show this is to kind of enunciate the modularity and reusability of the framework. For any given ETL process, we envision that the blue boxes stay common. You don't need to change the blue boxes. You bring your own transformation because it is specific to your application and your use case. Of course, that would differ. So bring the red box that says dataset transformation notebook. So that's a specific application logic you are bringing into the framework. And you need to bring your own inputs and define your outputs because they would also differ. So the raw, validated, refined red boxes indicate you point to the input files or streams or APIs, whatever your input data sets are going to be, and define what your outputs you want it to be by running the application logic that you are bringing in. But all other components, basically the orchestrator, the driver notebook, which is going to do some common things using common code, and it's going to generate logs, a very detailed high-level logs, low-level logs, as well as registering the data files and schema files. That's a concept of file registry, because it's pretty difficult to track metadata in storage like S3 or ADLS or file systems. So there is a concept and notion of file registry. So that's a common component, as well as the process configurations. So for any ETL applications, you define certain parameters, which are nothing but what are your input objects, output objects, what's your transformation notebook name and path, and some other things. And that's a process configuration. So those remain constant, right? And the green boxes indicate the storage layer, but we will focus more into the middle box today when we see the live demo of one application being run and how the driver notebook runs, how the common code behaves, and how it picks up the defined raw input paths and the objects using the configurations and generates the output data sets using the transformations that are supplied. So that's kind of overall flow and the diagram and deep dive we want to show. Again, this is work in progress. The intent was never to produce a commercial tool. It might look like and sound like, we're trying to build a commercial tool. We may get closer, and it would be nice if we really end up building a tool. But this is a lot closer and better, we thought, than doing siloed development by various developers and applying data processing over and over again on the same data sets and reduce those overlaps. So before we jump into actual demo, I will take a quick pause. If there are any questions, or comments? Okay, sounds like none. So I think people are excited to see the working demo, Mike.
Prasad, do you want to hit on the highlights first, or do you want to come out to this later?
I think we will come back and tie back and say what they saw, on the highlights.
Okay, sure. All right. Then let me go ahead and bring up a couple of things. So first of all, just wanted to call out in the beginning before we start the demo really. If anyone has any questions, during the demo, feel free to bring them up as we're going through stuff. I think that will just make it easier for us to kind of understand those questions in context and answer them a little bit better. So feel free to speak up or send some stuff in the chat. And Brandon, Dave, just let us know if some stuff comes in through the chat. So.
Yep, we'll do.
All right, so what I wanted to show first is really the data lake, because the data lake is the thing that really kind of controls the whole flow, the whole process, because not only do we have our actual data here, we also will have our configuration data. So the first kind of thing to notice here is we have 3 different folders, and they correspond to the same zones that we saw on one of these slides here that Prasad went over. So on our data lake storage, we have raw, validated, and refined. So that's these guys here. And if we go into raw, we kind of set this folder structure up like we would a database. So at the level below raw is kind of like our database level. And then below that is our schema level. And then below that is our table level. So really the data set that we're working with is Virginia Commonwealth revenue and expenditure data, which we've loaded a year's worth of data at this point just from 2019. So that's the data set that we're working with, and I'm going to show you guys what the revenue folder looks like under here. So this shows that this revenue data set is partitioned by a column called data date, and data date is really just telling us the date that the data came from. So in other words, like, what is this data? What date is this data as of? And in this case, the data set is a monthly data set. So we have this pattern of kind of year and then month. So we have 12 folders here. And if we jump into this, they're CSV files. So in each one of these folders, we'll see that we just have CSV files. We could have one or multiple files under these folders to Spark and Databricks. It doesn't really matter which we have. And so if I kind of show you guys what the data looks like. So this is an example of the revenue data. The expenditure data is very similar, so I won't show that, but we have a good variety of different kinds of columns here. Most of them are strings, but some of them are different. So we've got like an integer here for the year, and then we've got more of like a double or a decimal value here for the amount. So this is just ways of categorizing revenue for the state of Virginia. And then the actual amounts are here in this last column. And what we have set up also before we ran anything was a schema file that describes this data. Since this is CSV, it's not self-describing. So we wanted to make sure we had a schema file for this. We can see in the data file, we have the header at the top with all the column names, and those match up to our schema file here. And we just made this extremely basic schema file. For the most part, the only information in here is the list of columns, the data types for each one, and the whether or not they're nullable. So one thing to call out is we have used the actual Databricks data type class names here. So this ends up getting used in the code. There doesn't need to be a translation. So that's just one reason. That's just one reason why we did it. But basically, there's string type for all of them except for we've got the amount that's decimal type. And actually, this one is integer type. That one should be integer type. I think I have like an older version open. But yeah, so these are all defined already in the data lake. So if I go back, can go and take a look at where those schema files live. We have our metadata folder here outside of the 3 ingest zone folders. And then underneath here, we have a folder for the database again, and then the schema financial. And this is where all of our schema files live. So we have 2 that we definitely need for raw. For valid and refined, we have the schema files here, but the framework actually does support creating them based on whatever you do in your transformations. So whatever data types you have in the output of your transformations, that's what gets used for the schema, unless there's already a schema file. So we just have them here, but they don't actually need to be here. The raw ones do, though, because we're kind of expecting that any raw data that we get needs to have a schema. Otherwise, we want to protect against just data being dropped in and not knowing whether or not it's correct. So, and then if I jump into this control folder, this is really the kind of heart of the configuration. There's execution log, file registry, and process step config, or we usually just call it process config. And then we have schema files for those as well. The process config is the most important piece of this whole puzzle, I think. This is what drives like every process. So I have it here. It's in JSON format, which made it a little bit easier to work with. And I've also expanded it out so it's easier to see. But essentially, this will show you the IDs for the overall process that you're running, and as well as the individual steps. So, we might be trying to refine some data to calculate totals of revenues and expenditures. And so on our journey there, we'll have several steps. One is to validate the 2 raw data sets. And then the next one would be to actually do the aggregations to get to the totals. And then the final step is actually to land the data into the data warehouse. So just to kind of go through some more of these columns here, we've got, this is one of the most important ones, is the source objects, where we're describing one-to-many different data sets that are required for doing the transforming that you need to do to get to your output. So there could be one data set or there could be multiple. So here we're just dealing with revenue because this particular entry is all about just getting data into validated. So all we have to do is really schema checks. But in addition to source kind of information, we also have target information. So we know where we need to land the data. And so the framework can kind of take these pieces of information and it runs through the same code, the same notebook, but because of the differences in these values, it's able to actually do some unique processing that's required. Yeah, so I think that kind of covers this, and we'll show more details of like kind of what's going on with this process config in a second. That is actually all of the, that's all of the data lake, except for I just wanted to show that in our valid and refined folders, currently we have no data. So our demo is going to be populating that. But any questions before we jump into Databricks?
Yeah, Michael, this is Brandon.
Sure.
I had a question about how do you handle schema evolution?
Mm-hmm. Yeah, so we have 2 kind of approaches or 2 kinds of assumptions around how we're going to be receiving schema. So one is that someone can send us their data with a schema file, and we would expect that that schema file is correct. So we're not explicitly checking that it's correct, but we're expecting that it is. And so we would attempt to read the data with that schema, and if it's successful, then it kind of just continues on. But the other way is, as a platform, or a group on the platform. Maybe we want to restrict everyone to a particular schema. And we're saying that those responsible for sending us the data need to conform to a particular schema. In that case, we are going to actually read the data that they send us and analyze it and compare it with the actual schema file that we know is the allowed schema. So if there's an issue, then we'll fail it if there's any kind of discrepancy. But if there's something like, so on that side, we're going to fail it if there's any kind of differences. But in the first example, when they kind of control their own schema, we would allow schema evolution. If they add a column, that should work. If they remove a column, that should work. But if they change like a data type on a column, then that actually fails. And so what we're doing is we're using the Parquet format's merge schema option. Mm-hmm. And so that's kind of how you can control schema evolution with Parquet. But I know I've tested this out, and it seems to not like it when you change data types. Even if you go from like a string to an integer or something like, or an integer to a string, like, something that's going from more restrictive to less restrictive, it still kind of flags that as an issue. So did that answer your question, or is there more to it?
Yeah, that definitely answers.
Okay, awesome. All right, any other questions before we go into Databricks?
Hey, Mike, I have one question. It's David.
Sure.
For the JSON, are you managing that using Spark or using plain Python, like the actual metadata management stuff?
Yeah, so what we're doing is, we're landing this file in our metadata folders. And what we actually do is, I was experimenting with this, and I'm not sure if it actually worked properly, but I was trying to take this file, create a Databricks table on top of it, and also to do that according to like the exact schema and nullability that I defined in a separate schema file for this particular process config data. And I don't think that nullability is actually taken into account, but we do have this getting created as a table. And then from that point onward, we address this data through querying the table.
And the table provides better readability of that process config file, which we will see in Workspace, Databricks Workspace now.
Okay.
Yeah.
Is there any concerns with like the overhead of the fact that you're using Spark for that? I mean, I don't know. Just I've tried to do something similar before, and it's a little bit slow in terms of reading the metadata.
Yeah. I think it depends. It's kind of, it takes a second or two to read it, but we only have to read it once for each step. So it's not like a huge burden. I would say with the other metadata sets, it's probably more of a burden. Just like the execution log, we actually read and write to this, whereas we're only reading once from the process config. And then the file registry, we also read and write to that. So I would say these ones probably have more of a burden than this one. It's not too bad, but I think some of it could be addressed by pumping up the cluster size and the scaling it out. But there could be some more efficient ways to do it for sure.
Yeah.
Let's suppose the target object I want to write into the two locations. So in that case, the source is one source, the same source data I want to write into the two objects are like two data frames. Can I write this one?
Not currently. So we just kind of assume there'd be a single output. So you can see here in the config, it's not like a list of objects like we have for the source. It's just a single column for each attribute for the target. So yeah, currently it only supports writing to one output location. That's a good idea though, because what could happen is when we get to the point where Sorry. Someone trying to speak? Okay. Well, I was just saying that it's a good point, because when we get to the point where we actually create the refined data set, we could have done it so maybe we could write both to the refined portion of the data lake as well as to the actual the SQL table on the data warehouse as well in one shot. But instead we have it kind of a separate execution. Yeah. Good question.
Thank you.
Yeah, and I think this may work a little better because sometimes you may want to write a refined data set to the lake, but may not always want to put that into the table yet. So this allows us the flexibility to run. So each of this, if you see this, is runs as a step. And I think the question that you asked, right, is another target possible? Yeah, you add another step.
Yeah, you could do that too.
Add another step, it becomes another target.
Yep.
So that's
yeah,
one
so
way.
all of your source information could be the same. You could do the, everything would be the same except for your target. Yeah.
Let's suppose we are reading a couple of source data. Some of the source data, like a more amount of, size is like a 10 GB, 100 GB is there. Are you keeping cache in between? Is there any configuration parameter, data frame dot cache equal to enable kind of things? Are you processing entire data set? The action we are doing last, right? Maybe if you are processing like a 1 TB data or 100 GB data, in that case, how you are processing? Are you doing any configuration parameter also?
No, so we don't have caching like that, so that I could kind of remember. I guess it's whatever is standard to Databricks clusters. So you could keep the cluster up and running, and so whatever it had run previously, it probably has that cached in some way. But we don't have any kind of explicit caching mechanism. That being said, what you could do to kind of reduce the timing and make it a little bit faster, more performant, is to partition the data. So we could have, we're processing a smaller subset of data each time, and we don't necessarily really need to read, all the historical data. We just need to read the current data. So that's one thing that's built into the framework. But yeah, we don't have explicit caching.
Yeah, thank you.
Yep, no problem. All right. Anything else? Okay. All right. So just show you guys what Azure Databricks looks like. Pretty sure this looks fairly similar to like Azure Databricks on AWS, but you're brought to this page initially, and you've got a bunch of options over here on the left. One of the important ones that we want to show you today is this data tab. So the data tab is what shows you all of the databases and tables that you have created over your file-based data. And this could be stuff that exists within the Databricks workspace itself, so kind of internal data, or it could be stuff that exists on an external storage, which is what we're doing with our Azure Data Lake Store. So here we can kind of go through, and I have these three databases set up here. Right now we have nothing in them, and that's purposeful. So what's going to happen here is our framework, the first time you run it, really just requires that you have all the configuration data and the data itself in your data lake, but it doesn't require you to really do any kind of table setup in Databricks. It will actually take care of that for you for the first run. So we should see when we run this that this stuff starts getting populated. So let me go ahead and kind of show, I created this notebook really as like more of an orchestrator. It's one example of a way that you can orchestrate processes on Databricks, but there's so many other tools that you could use, like Azure Data Factory or something else. So here is where we are really kind of looping over our process configuration rows, and we're going to start kicking off a notebook run for each of our processes. And there's this command that you can use in Databricks called dbutils.notebook.run, and that allows you to do just that. So you can call a particular notebook here. This is our main ETL driver. That's going to be the same notebook we call every process with. And the things that differentiate it are really the process name and the ingest zone here, as well as you could pass in a data date, which is going to be like, you could do it, but our process also will calculate the data date if you don't pass it in explicitly based on whatever was run last. So by passing in the process name and ingest zone, we can actually find the specific row in our configuration data that will allow us to know what we're doing, right? To actually read the row from here and get all the information. So the first one, process name is financial revenue, and the ingest zone is, it should be 2 right here. And so if we show what we ran, the first thing is financial revenue and ingest zone is 2. So that will start running the process for that step. And if I show the data again, we can see now that all of our metadata tables have been set up. We can take a look at one of them, like the process step config. And we can see also that I think the data has started to populate here as well. So we've got our table for financial expenditure and financial revenue that were just created and valid. And revenue actually was just created as well, or refined was just created as well. But we'll kind of go through that after we step through what the notebook's actually doing. But we can see here, Dave, going back to your question, this is how we're setting up our metadata. So we just read in our file as a table, and then we just kind of interpret, we query the table and isolate to the correct row that we need, and then start using all the attributes. So, all right, let me go to the driver. First thing to note really about this driver notebook is kind of the stuff at the top here. These are called Databricks widgets, and the widgets are just parameters. So this is what really allowed us to do this framework at all, like to achieve like a reusable framework, so that we could actually pass in different values for our parameters to the same notebook. So here it's already set up for data date of January 2019 and financial revenue ingest zone 2. So that means we're doing the valid stage. We can do stuff like making sure that particular Spark configurations are set up. Some of these things are pretty important for the kinds of operations that we're going to do. And then this is a section that actually deals with reading the widget parameters. So it's pretty simple. It's just another Databricks utility kind of function to read it. And then once you do that, you put it into Python variables, and then you can use them throughout. This part here about importing the common code. So we can kind of go back to our diagram here. And we've got our orchestrator, which we looked at, kind of that other notebook. And then we were in the ETL driver notebook. But then from within the ETL driver notebook, we want to call a statement that's going to allow us to use the code in the common code notebook. So I already showed you the dbutils.notebook.run option that Databricks gives you to run a notebook from another notebook. But in this case, we wanted to use this %run. And we did a lot of comparison back and forth on these two options. But %run really allows you to execute another notebook. But if everything is organized into Python classes and functions, then it actually acts like more of like a Python import statement. So you can actually get access to all of the classes and functions that exist within this other notebook from your calling notebook from the ETL driver. And so that was one of the biggest revelations for us, is that we could do that, have access to all the code that we need from then on, and use it where we needed to in the subsequent steps. So here, mount file system. this mount ADLS Gen 2, this actually comes from our common code. So this is the common code notebook. There's a lot of stuff in here, but we can see here, this is the class that it actually imported and used. And so this could be parameterized. We haven't done that yet, but for now it's just kind of, set up, hard-coded. But once we mount the file system, then we can use it just like Databricks internal file system. So the next step is actually to get that process config row. So we have our parameters, and now we need to apply them to our process config to get back the correct row. And so that's all that this is doing. And we can see in the output, the format that we get this back in is actually, it's not a data frame. We output it to the actual row object, like a Spark row object. So this allows us to then get the individual pieces from that row and use it within Python code. So there we get that. Once we know what we're running for now, we can start a Python logger and kind of tell it, hey, we're logging for this particular process. So that's one revelation we found as well, that you can do Python logging within Databricks. So we have something set up for that. The next step is really around reading the execution log, which, at this point, this is our first run, there's nothing in it. So it'll just kind of return an empty data frame. And there is some date calculation logic around this too. Like I said, you don't always have to pass in the data date that you're going to process for. It can actually calculate it based on, whatever was last successful, it'll do like the next iteration. But we'll skip over that. So here's the meat of this whole notebook, I think, is dealing with this ETL runner. So ETL runner, we created this class that has 3 different pieces to it. There's reading the source data, there's transforming that data, and then there's writing that as output. And so that's what the ETL runner class does. It kind of is over all those functions. What we're showing here, I think if we go up a little bit, this way of actually using the classes that we imported in the previous in one of the earlier steps. This is one way you can do it, where you can actually just write out the class itself. But there's another way where everything once you import it, everything goes into the Python globals, and then you can actually dynamically specify, what your class is going to be. So in our case, we're calling the ETL runner class, but we're kind of appending onto the end of it this ingest zone. So effectively, it's going to call the ETL runner 2 class in our case. And we set this up this way because there are certain zones when we're going from raw to valid, or going from valid to refined. We're going to have a transformation notebook, and valid. You might not always do anything in that transformation notebook, but if you wanted to do some DQ checks, you could. But when you start talking about going from the refined area of the data lake to the actual data warehouse table, then you're not actually running transformations anymore. There's no need to do that. You're just trying to take the data that's already there on the lake and land it into the table. So in this case, we kind of overrode the parent ETL runner class with a child class for the ingest zone of once we want to take data to the data lake, or sorry, the data warehouse, it will actually skip the transformation step. And that way we could still have all of these common objects and be able to deal with little intricate differences among the different ingest zones without having to create a new notebook for every single process. The other way that we could have done this was by just kind of introducing a lot more if statements into our common code, which we were trying to avoid. So just trying to make it as clean as we could. Any questions on this so far? All right. And once now we have this ETL runner class, like I said, the first thing that it does is read input data. So this was going to go and look at our process config, and it's going to go through, find all the data at where we're telling it exists on the data lake and pull that in. The next part is dealing with transformations. And this was kind of like an unfortunate issue here that we ran into with the limitation of Databricks, really. So with this %run command, it works super well for how we're trying to use it, except that you cannot parameterize this this actual like path to your notebook. So ideally, it would have been nice for it to put in each row in our process config, like the name of the path to the notebook that does our transformations. But we were not able to do that because we wouldn't be able to substitute it here. And so what we did instead of that is kind of a bit of a creative problem solving here, is we put all of our import statements that we would need in this other notebook. And so when we run this notebook, it's going to basically import all of the transformation classes that across, basically all the classes that have been defined. So that's what this notebook is. The sole purpose is just to get us the classes for doing transformations accessible within the ETL driver. And so we kind of had to brute force it, I guess, like, just put everything together and import it all. But it doesn't take very long because everything is defined in a class. So it's not really like running anything. It's just kind of, allowing the class to be called. So, and then once we have that, now we can actually do this a transformation. So the transform is something I wanted to show in the common code, just one particular aspect of it. All right, so here we can see this is how we're getting the transformation class. After we do that notebook import, we are actually looking for a class that's called the process name, and then __ the ingest zone. And then once we identify that, we now have the class that we can call its run method. And then that's, we're assuming that every class that gets created for transformations has a run method, and we can just call that to do all of our transformations. And if we kind of open up one of them to show you, so in our case, our example was running financial revenue for ingest zone 2. So our transformation notebook looks like this with a class that's named that way. And then the other thing to note here is we have our run method, and the run method can call any number of other methods to actually do the transformations. In our case, it's super simple because for raw to validated, it's really we're just selecting everything. So this is an example of just a very, very simple transformation notebook setup. But if you wanted to do additional stuff like DQ checks on this, you could put that logic in here. So that's why we have that step. So then if we come back, to the driver, the last part here is dealing with ETL runner, is to write the output data. And so that just takes the data frame that gets output from your transformations. It will write that data frame to wherever the destination is, whether that's on the SQL Data Lake, the Data Warehouse, or the data lake itself. And then the final steps here is just to record, success results in the execution log, and to stop the Python logging. And that's essentially how the driver works. Any questions on the driver operations?
The logging things, where you are writing the logs?
What did you say about logs? Sorry, I missed that.
Yes, are you writing any path of driver node, or where we are writing exactly?
Yeah, so if we look at, we're actually writing some Python logs. And so underneath, we can see now, and under valid, we have some folders here that were created when we ran our process. Logs has, we're landing some of the Python logging here. And so if I open this up, And let's see, once this finishes, we'll get this open. But yeah, it's standard Python logging. So open that up. So we can see, like, you can set it up just like you could with any other Python logging, where you have like a timestamp. It tells you the line and everything. And so we have, like, you know, just wherever we've logged in our common code, that's what shows up here. So we can see where, you know, found that these metadata tables didn't exist, so it created them. It was pulling data, you know, it was pulling the source data. It put entries into the file registry, and it did all sorts of things. So that's one piece of logging. The other piece of logging is really what happens on the Databricks cluster itself, just kind of automatically. So you have access to all those, the cluster logs as well. And then in addition, in our execution log, we also, you know, kind of will record the results of the overall run. So if I go here into the execution log, I can see here that this process ran, and, you know, here's the path to the Python log file we just looked at, and it'll tell you, yeah, if it succeeded or not, and if it fails, it'll record the error message as well. So, all right. If we come back to this overall notebook here that we used, it looks like everything succeeded. And we already looked at, you know, kind of these log files. But if we go back to see that the data exists now. So revenue, we can see that a folder here for the 2019-01 date was added. And we can see our data is written here. And in our process config, we specified the output to be in Parquet format. So we can see that it was created as Parquet. And same with expenditure, we have our data here. Expenditure is a little bit bigger of a data set. So, you know, Spark decided that it needed 4 different partitions here for the actual output data, which is fine. So it just decided that it needed 4 files and created those. And if we come back to refined, we'll see the same kind of thing. We have our data under refined. So all that data is here as well. If we go to the SQL Data Warehouse, I forgot to kind of show this in the beginning, but when I ran this at the beginning of our presentation, our financial totals data table did not exist. And so if I run this now, what I should see is our 2019-01 data. So we can see it landed here, and our transformations were dealing around, like, summing up revenue and expenditure and grouping them by these different columns here. So we can see that data has landed. If I go back, I forgot also to show the notebook, the transformation notebook for this. So we saw, like, earlier, this transformation notebook was super simple, just like a select star for the validated step. But when we wanted to create that totals data set, we did some more, you know, more advanced SQL. You know, just, it's still basic, but a lot more advanced than a select star. So we've got, you know, our sums that are happening, kind of common stuff, common categories between expenditure. We've got unique revenue only categories that we're summing here, and expenditure only that we're summing here, and then we're unioning them all together. And so we can cast here, we can cast our data types, and then those kind of show up in our data warehouse table. So Databricks will actually create this table for us using the SQL Synapse connector. And so we can see here, you know, our revenue and expenditure are the same data set, and fiscal year also, or the same data type, and fiscal year also is integer. It defaults all strings to nvarchar 4000. So that's one thing that I'm still kind of working on, trying to figure out how do we get this to be more precise. Like, you know, if data date's always going to be, I don't know, 6 characters, maybe we want it to be a character 6 or something. So kind of working through trying to figure that out. But for now, we just kind of accepted the defaults. All right, and then the last thing that we can show here is that just like in the data warehouse, we query the data, we can also query it within Databricks. So now that everything has been set up, we got our totals processed on the data lake, we can run a query against this table, and we can see that data is in here. All right, so that is pretty much I think that's everything I wanted to show for the demo, but any questions?
Yeah, Michael, this is Brandon again. I was curious of how do you process reruns or go back and redo old data dates and things like that?
Yeah, that's a good question. So you could do something where whatever your execution mechanism is, whether it's a notebook like this one, or it's some external tool, you can just call the notebook and pass in your specific data date. And it can be an older one. That's fine. What actually happens is in the process config, let me show this. It gives you a lot of options for how you want to write your data. So we have, a target file type being Parquet, or you can set it to CSV, JSON, Delta, whatever you want to do. You can say for like CSV, whether or not it has a header, kind of the delimiter encoding, partition columns. So anything that, if your partitioning is different from just data date, you can specify that as well. And then we have our population method, which would be either append or overwrite. And so if you do append, that will just assume that, duplicate data is okay if you reprocessed a date. But by doing overwrite here, we actually use, I think it's a Hive capability, where you can overwrite only the partitions, dynamic partitions that exist in your data that you're working with in that current run. So it will get rid of everything in those partitions and then replace them with whatever your current run is. So if you wanted to rerun a particular date to update something, maybe some of the source data changed, then you could do that very simply just by executing it again. There's also, with Delta, we experimented with a target population method of merge. And so you can actually have a merge statement, like a SQL merge statement, and that works pretty well as well. But for this demo, we didn't focus on Delta. We just kind of used regular Databricks tables. Good question.
Yeah, that's a good question. If you quickly want to show them the data lake, right, the partition folders is what Mike is referring to. So if you go to any valid or refined, you see that data date equal to something.
Yep.
If you run for another date, it's another folder is going to pop up with that date, which is like partition in that table.
Let me do that real quick too. And we should be able to see something come across here the next few seconds, but yeah, we can kind of show that it'll just add another folder. So.
Hey Mike, did you say you decided not to use Delta Lake?
Yeah, for the purpose of this demo, the framework, we're not sure at this stage if it completely supports Delta, and that's one of our lessons learned, which we'll get to after this. But Delta tables and regular Databricks tables can't always be addressed in the same way. Sometimes certain functions that work on regular tables don't work on Delta, such as like stuff dealing with partitions. It doesn't let you do some of the same commands. And so, yeah, we just kind of try to make it simpler for this, but we're definitely looking at Delta for the refined and for the valid data, I believe. And Prasad could probably add a ton more to this than I can about, some of the stuff we're excited about for Delta. So, yeah, Prasad, did you want to kind of add a little bit more to what you think Delta could be used for?
Yeah, so I think few things top of my head are the schema evaluation works better, we found, with Delta tables. When there is a DDL on source and we want to gracefully merge that was good. We found that you could vacuum the tables to keep the data more current and archive what you don't want. The transaction logging capability was really good, and that's what we are planning to use and explore more. Create a Delta Lake, basically.
Hey, Mike or Prasad, you guys want to, for those who are uninitiated, maybe talk like just 1 second what that is, Delta Lake capability?
Yeah, sure. Yeah, real quick before we do that. So we just reran this for a second date here for February. So we could see that that additional folder showed up in our data lake. So that's just kind of what happens when you run multiple dates. Yeah, so Delta it's now open source. It wasn't to begin with. It was started by the Databricks crew, but it's kind of a way of creating tables on Databricks that brings a lot of like traditional SQL, like relational data warehouse kind of capability to Spark. And so one of the things there is it'll keep track of transactions instead of, just hoping that, you run this and let's say, I was talking about that example of it's going to like replace a partition. Maybe it fails in the middle and now you've lost all your data. It doesn't roll back if you're using a regular table. But if you're using a Delta table, it gives you that kind of transaction capability and rollback if it were to fail in the middle of something. And there's a lot more to it. It gives you some light history, but the history is really just there in case you make a mistake and you have to go back to an older version. It's not meant to be like ongoing history, but there is that capability too. And Prasad, you know a lot more than me.
Yeah, there are really some good features they are rolling out, and as Mike was saying, it's getting closer to a relational database level of, not there yet, or I don't know whether the intent is that, but for example, now you can index columns. It's called Z-order indexing.
Yeah.
You can collect statistics on columns. You can now point your BI tools like Click or Tableau or using JDBC your driver to the Delta Lake tables and just produce reports. So that was one of the big, I think, the problem with the Hadoop or file system based data was like BI tools were not efficient in generating reports on them, but now you can if you are using Delta Lake.
I think the biggest thing for us was the ability to do updates.
Yeah.
So that was huge. You couldn't do that with just regular Parquet tables.
Yeah. And that's true. You can do updates, you can do deletes, and you can do merges, and you can't do any of those things with regular tables. Regular tables only let you do appending or inserting, or a partition like overwriting, which is kind of gives you that update functionality in certain cases.
Hey, Mike, I haven't seen the Synapse thing. Can you show that code that's doing the load?
Yeah.
Showing that part.
Sure. Yeah, it's super simple. I think it's just there was a decent amount of setup. So one thing that's interesting is with the SQL Data Warehouse, like Synapse connector. Let me get down to it. So you have to have another data storage account set up so that it can kind of stage the data. So when it writes data from Databricks or from your data lake into the data warehouse, it has to stage the data in some separate like storage container, and then it will load it from there using Polybase or some like sort of copy command. I don't know. I think it's using Polybase for us, but it'll take that into the data warehouse from that staging location. And similarly, when you read from the data warehouse, it has to stage that as well, and then bring it into your data lake or into your Databricks. So yeah, that was interesting. And I can show, we had to have our AWS Gen 2 created with a separate storage account for that. But that was one of the interesting findings from this.
And that part is kind of understandable, David, because what it is doing is staging the data in a temp space, and it's going to do bulk copy into Synapse using Polybase. And Polybase requires that external tables and whatnot, right? All that setup, external source, external file format, external tables. And when we see the SQL log on the Synapse side, actually the driver is implementing all of that behind the scenes, because the log output shows on the SQL Data Warehouse side that all of those actions are happening without we need. So the beauty was like, we don't have to do those commands now ourselves to load data or bulk copy data from ADLS to Synapse. We don't have to do that. It's taken care in that connector.
Yeah, so this is our code here to do that. We had a separate kind of class that just kind of creates the connection string to the data warehouse. And then down here, this is the command that takes it from the data frame and writes it to the actual SQL Data Warehouse table. So you have to pass this as the format, which allows it to use that connector. And you can pass in some pre-actions. So what we did is like, you know, if you had set this to an overwrite kind of population method, then we would truncate the table before writing to it every time. So you can do kind of preload SQL that way. And then this is the actual connection. This is where, like, I was talking about the string, how it's defaulting to nvarchar 4000. So that's because we put this here. It actually defaults to a lower amount, which we were finding we're getting issues with, like, you know, cutting off data and it was failing. So we raised it to the maximum here. But yeah, this is where you name the actual table. And there are some options. I think Prasad added this with the clustered column store index. You can specify what kind of index you wanted to use and what kind of distribution method. Yeah, so it's all within like the read and the write Spark commands.
Cool. One learning we had on line 48, you see that it is talking about Polybase, the right semantics. So by default, this is not turned on in Spark. I don't know why. But we've learned that you have to explicitly set that so it enforces bulk load instead of, otherwise it's going to generate insert statements per row, which is not what we want.
That's cool. Thank you.
Yep.
I've not tried this, so this is good learnings.
Mm-hmm. Yep. And I'll kind of come ahead to just like give a little bit of a wrap up of what we looked at the demo, and then kind of some key lessons learned, and then any other questions you guys have, feel free to throw them out at that point. So, all right. So the main components that we talked about on the notebook kind of level were our ETL driver, which is directing every process. So that's going to be executed with different parameters depending on the process. Our common code notebook, which gets read from the ETL driver to actually do all of the processing. So all of our logic is really in that common code. And then we have our individual transformation notebooks that contain the code that's specific to each individual process, each individual step even. Metadata files, so the process step config is the core. That's absolutely needed to actually tell what we're actually going to do, tell the driver what to do. The execution log is keeping track of the results of each run, success or failure. And then file registry is marrying the schema with the actual data itself. So we can kind of go back and take a look at that. And the code can use it to make sure it uses the correct schema with the correct files. Key lessons learned. So kind of have it separated into two sections. The two biggest lessons learned are that you can do metadata driven framework, and it seems to work pretty well. And then the other thing is that you can use both files and tables, and we believe that using both is a good option. So we'll kind of go into each of these. So metadata driven, as we showed, you can use configuration data and the parameters in the main driver notebook and swap those out for your different processes, and avoid having to recreate a lot of the same steps that every single ETL process is going to have to do, like actually finding out what source data it needs to run for and importing that into memory, and then actually, like, running the transformations and then outputting the results. So those things can be standardized and centrally managed, and then you just really have to worry about your actual business logic for your process. And I mentioned this about the %run and the dbutils.notebook.run. I didn't cover so much of the dbutils one, but the other thing to keep in mind about this is like it doesn't let you return data. So if we kind of go back and we look at this real quick, because I think this is an important concept. And something failed here, but that's okay. When we ran this notebook, this is that method. It created these like little jobs here, you can see. And what's cool about this is you can actually open them up, and it's an ephemeral Databricks job. You can see like exactly what happened in your run of your process. So it'll show you the ETL driver notebook, which is the one we called, and then it shows you the individual output of like every step, you know, whatever we've allowed to be outputted. So it's going to show us like all of our logging statements and everything. So that's really cool. It makes troubleshooting a lot easier, I think. But the other thing with this is there's some overhead involved when you create a Databricks job. And you can pass in like only kind of string data here, and you can return only string data. So like, let's say in our ETL driver, we set up a bunch of data frames. You can't really pass that into another notebook by using this function, unless you were to like store it and you made this other notebook read from wherever you stored it from. Like, it's not an easy way of passing things back and forth. Whereas the %run allowed us to basically just import all the code into the main notebook and use it, and that way it has access to all of the inputs and outputs and everything. So that was why we gravitated towards that %run option as opposed to this, those couple of reasons. The other big piece here is about files and tables. So one thing that we notice is if you were to create a regular Databricks table, you're kind of solidifying that schema. So the schema is not, you're not going to like easily change that schema unless you actually drop the table and recreate it. And so when we're dealing with the possibility of schema evolution, we didn't want our code to be reading from the table every time. So we actually read from the files every time. So that allowed us to kind of swap in schema files, the correct schema file, or to read it without the schema for that example where we actually have to validate if the data matches the schema that they sent us. So that gave us a lot more flexibility working with the files themselves. But with Delta, it might change some things where you could actually do a lot of that stuff as tables. But for non-Delta, this is kind of how we set it up. Tables are super useful. Like Prasad mentioned, you can connect them to other tools, external tools using JDBC. They will exist in like the Hive Metastore within Databricks. So like, you know, we saw them show up in the notebook, or sorry, in the workspace where you could see all the tables. So it's just like a lot easier for users to identify what data is on your data lake. And kind of to query the data as well. It's a one-step process. It's just a select statement. There's not any kind of setup that needs to be done. So tables are really good for users, but in terms of processing, we found that files were easier to use. As I said, Delta can alleviate some of these concerns, but there are other concerns and like other issues that Delta brings with it. So if you're not keeping on top of getting rid of your history of your table, you don't have that set to a configuration that's frequent enough, it can really slow down performance, even though Delta gives you like, you know, indexing options. And Delta doesn't perform exactly the same way in all aspects. So for that partition overriding topic that we discussed, we can do that very easily using like a Hive table, a regular Databricks table. But for Delta, it required some extra coding, and it had to use like this replace where option instead of, it doesn't actually work with dynamic partition overrides. So there's just kind of some little like subtle differences that you would never know and they don't tell you until you actually start working with it. So the hardest thing is to try to design a framework that works perfectly well for both. And so that's kind of like what we set out to do at first, and then we kind of stopped using Delta for this demo because of all the differences. So that's just one thing to keep in mind. It's not super easy to merge both. So Python is a really viable option in Databricks. Pretty much like most of what's supported by Scala, I think, is supported by Python pretty quickly thereafter. And you can use Python, native Python stuff, as well as Spark, PySpark Python operations. So you can kind of mix and match those as you need to, which is really, really nice. Performance was one of those tricky topics that we had to deal with. We were, at one point at Markel, we were dealing with these JSON files. And so we had to actually like take relational data and convert it into JSON files. And we had to write out every row in a data frame as a JSON file. And that was, we ran into a lot of performance issues with that. Eventually got somewhere that actually was decent. But we had to tweak a lot of variables. So you've got your cluster size, like vertical and horizontal, that you can tweak. You've got partitioning that Spark does on the data frames themselves. So maybe Spark is deciding that you need far fewer partitions than you actually do need. And when you have a larger cluster, like a wider cluster, you need more partitions so that it can chunk up the data small enough to send it to all those different nodes to process in parallel. And if you don't have your partitioning set up to be, high enough, then it's not going to fully utilize your cluster nodes. So we ran into that issue as well. We had to do some tweaking. The other thing too is if you're trying to do Python specific, like Python native operations over Spark native, you're going to have some performance issues because it can't parallelize and distribute that. You're just going to be running single node kind of operations with that. So those are a lot of the key lessons learned on the performance side. So if you can use a Spark data frame, I would much recommend that over doing like a Pandas data frame or working with anything else in native Python, any other kind of structures. So development environment, this is another thing that we found was a little painful and more painful as we went along. Working within the Databricks web UI isn't the best. It's slow at times. Once you put enough code into a single notebook cell, it really slows down, and like you can type some keystrokes and it'll take several seconds for it to register anything. So I think it has to do with the idea that multiple people can work on the same notebook at once, and so there's like a lot of there must be doing a lot behind the scenes to make sure like you see the other person's notebook updates and they see yours. But yeah, that's kind of a headache that we keep running into. There's an option to develop on premises called Databricks Connect, and that actually will still run your code using the Azure Databricks cluster, but it doesn't have all the features such as streaming. You can't really do streaming development when you're using Databricks Connect. So there's some trade-offs that are not ideal. Also with the Git integration, currently it's at a per notebook level. So like it's almost impossible to like actually be able to switch out from one branch to a completely different branch and have it like, update all the other notebooks accordingly to be from that branch. You have to individually like switch out the branch on each notebook. So it gets super hard to manage. And so like there are some interesting things you can do to get around that, but there's nothing that Databricks offers that really kind of fixes that issue yet, although they are planning on creating an option that gives you more of that kind of like branch level Git integration. So I think that kind of covers everything there. So any questions from any of that last stuff that we were just talking about, or anything overall?
Looks
I hope I
like.
didn't lose anybody in that last
Yeah.
that last part. So yeah, don't be shy. Like, feel free to speak up and ask me questions about this stuff if you want to.
So how to pass the daily data or partition date dynamically through notebook? I think we are running the notebook, right? Something you hard coded the in the date partition or whatever the runtime arguments in the one notebook, right? If I want to run in the production environment, the partition or run date or load date is coming as a dynamically. How to pass that value?
Yeah, so when you don't want to tell it the explicit data date to use, you can just not pass it, and there's logic that will read from the execution log. So we can kind of show the execution log again. And it basically just finds, for the process that you're running, what is the last successful run date, or what's the last successful data date, and then it'll increment to the next one. So if your data, and right now, I think we only have it set up to work with monthly or daily kind of data dates. So if it's 2019-01 for January or 2019-01-01 for January 1st, I think that both of those should work. And so if you've already processed this one, it's successful. The next time you try to run this same process here, it will run for the next date. So 2019-02. And that's how we would run it in production. Is the first time you might need to specify the date, but then every other time should be left up to the code to figure it out. Good question.
So you are saying that we have the couple of notebooks is there. We are calling from the one notebook to another notebook, right? Can you please show me where exactly we are calling one notebook to other notebook?
Yeah. So ETL driver. This is one example here. I'm just using that %run command, which, like as I mentioned, it acts like a Python import. So we're saying, like, basically import all the code that is defined in this common code notebook, which is over here. And as long as you've defined all your code in like kind of classes or in just kind of separate functions like here, it should be able to import all those. And then you have access to use them within this overall notebook that you imported from.
Okay.
So here, like, I just ran this. When I run this with the common code, and I got my mount class identified here, I can then use it directly in the next step.
Okay, got it. Yeah.
Yep.
So we are copying all our notebooks inside the common underscore code location, whichever the notebooks is there, right? Yes.
This goes to the actual notebook itself. So like the notebooks don't have extensions in here. If you look at the workspace, yeah. So here's our workspace, and under common, we have a driver folder, and then we have our notebook. So this is the actual common code notebook that we're importing, but there's no extension. So we actually give it the path all the way to the notebook itself.
Oh.
For some reason, it's not closing. There we go.
Yeah. Got it. Yeah.
Okay, great. All right, questions, more questions. Dave, I know you have another one.
I'll ping you on Slack, Mike.
Okay. You're going to ping me about the failure that we had, the error that came up?
Yeah. Nice job, though. Enjoyed it.
Yeah.
Yeah, really appreciate you guys sharing this. This is good.
Yeah, thank you.
Yep.
Thank you, guys. And you can ping us on Slack channel here if you have a question later. So.
Yep. I was just going to say, I appreciate everyone coming. The talk will be up on our YouTube channel, and it'll be up on LinkedIn, and we'll post it in the Meetup after this, along with the survey. So if you wouldn't mind filling that out. Yeah, I appreciate everyone coming. And I'm sure these guys can answer any questions you have in the Slack channel or offline.
Can we get the source code, these notebooks?
Yeah, if if anyone's interested in the slides or the source code, we can pull up afterwards and share those along with the with everything else. Prasad.
Yeah, so we are not open sourcing the code itself at this time. Slides are okay. I think the recording already shows the slides and some code snippets.
Yep.
But we are not open sourcing the code yet.
Yeah,
maybe someday. Maybe someday.
The recording just got much more valuable.
There you go. Yeah, but we're happy to answer any questions, as we mentioned. Like, if you have specific questions about how we're doing certain things, yeah, we're happy to respond. So. Yeah.
Cool. All right. Thanks everyone for joining.
Okay. Thank you very much.
Thank you all. Bye.
Soon.
Okay. Bye.